Okay, so in this code last week, what we did was we made a list of students and we populated the list with a bunch of people so that we had some test data. We made a file that we were going to write to. We turned that file object into a paths, the file string into a paths object. So remember we said that file name might actually be a complete path name, which is why the word path appears. Turns out for buffered writer, you have to say how you're going to write it out. So we're choosing to write it out in normal ASCII text. And then we had this bit of code here that had a try-catch block. And the try-catch block is sort of like an if-else. It's like, if this thing succeeds, then do the code inside the try block. If it fails, do the code inside the catch block, which in this case is basically just print an error message and end the program. Okay. This, by the way, is also the new Java 7 form of a try-catch block. And one of the things that's coded in it that you don't see is that when that try-catch block ends, it will actually close the file for you automatically. It used to be in the previous versions of Java that when you did this sort of thing, you always had to have something afterwards that closed the file because there's a limit on the amount of open files that you could have. And people would forget to do that, and then eventually they'd open and close file or open enough files that they wouldn't be able to open anymore. Okay? So now it's essentially built in with that new Java 7 syntax. And so what's happening here is the files class, you give it a file name, and it will magically create one of these buffered writer objects for you, and it will give you back something that is now basically attached to the file. So whenever you want to write something to the file, you use that writer variable to do the work. And so we wrote a loop that said, let's go through all of the students on the list, and let's gather up all of the information for one student into a string, and then we'll call the writer to write that out to whatever file it's got open, and remember to append a new line onto the end of the thing, so that we've now got one line written out to a file, and do that for multiple students. Okay. Questions about that so far? Okay, so here's one of the things that happens in even a fairly simple program, is that now all of a sudden this thing is starting to get complicated, because as I'm reading it, I'm looking and going, oh, let's see, what did they do first? Oh, they opened a file. Now they're going through all of the students. What are they doing with each one of the students? Oh, it looks like they're gathering up the information so that they can write out one student. And then they're going to go back and write out another student. Okay? So it would be nice if I could sort of simplify the thought process of what's going on in here. Okay? And simplifying the thought process in programming languages usually means, let's turn that thing into a method. Okay? So in place of all of this code, I do that with risk. I would rather say something like that. So now the for each loop says, go through each of these things and write out one student, and we'll pass it out along who is the thing that's supposed to be written. Okay. So now let me go down here and write private static write one student. I'll write the method down here, and I'm just going to paste all of that code inside that we had before. The thing that's being passed in as the first parameter is student who, and that gets rid of the errors for the who variable. And it looks like the other thing that I need to pass in is that writer object. And the writer object is defined right there. So I'm going to steal that, and I'm going to add it as the second argument onto here. And then I'm going to make sure that we pass in who and the writer object. And let's just see what, did I spell it correctly? No, forgot the O. There we go. Save it. Check and see what other error it says. Still didn't get it right. See what it's complaining about here. Oh, no return type, void. Won't bother with errors. And go down here, and this thing can now return an error. So the error that can be returned from that thing either needs to be surrounded by a try-catch block like that one was, or the other thing is we can just use the throw, which basically says I'm going to ignore the error, pass it up, and eventually the program will die if nobody deals with it. So let's just add a throws declaration on this. That's probably the simplest way. And save that, and if I'm lucky, all the errors have gone away. Okay? So there's a fairly typical way of simplifying your code, right? I took all of the stuff that looked like it was working together and said, oh, what's that doing? Gave it a name. Took all of the code that I now had a name for, shoved it into a method, right? Wrapped it into a method, and then figured out, oh, what variables am I using here? Those variables have to be added with their definition here. I can use the same names. And here, I'll just use the same names that I used before, and now it passes in and it's now a method. And the end result is that it makes this code a lot simpler. Right? Because now this code is just, oh, go through all the students and write one of them out. Got it. Right? And now my brain doesn't have to think about all of that other gobbledygook that was in it. Right? Questions about that? How about if we do it one more time? What's the purpose of all of this code in general? Open the file, reconstitute, close the file. So if this is writing one student, then this is writing all of the students to a file. Okay? Which part of it is writing the students to a file? How much of that code? Mostly the for loop plus this try catch gobbledygook, right? So maybe we could turn this into a method too that's write students to file. Supply the students and the name of the file that we wanted written to, and then all this would go away. Okay. So I'll play the same game here. At some point, this particular stuff is really just write all students to file, and the thing that you would give it is probably the file name and all students. And hopefully that would do the work. So what we'll do now is we'll go down here and we'll make a method. Oops, just want that word. And it takes in a path. Actually, we'll change this to file. It takes a path, which is our file, and it also takes in. Is that it? Yeah, could be. And we'll cut out all of that, and we'll drop it into that method. So it looks like we need a path, and we need list of all students. Save that, and it's probably going to complain about my naming again. Oops. Bracket missing there. To get the arguments right. Looking to see what it's complaining about. Oh, so I'm just supplying a, thinks I'm just supplying a path.
Right to where the list is set, right in front of your student.
Oh, thanks. And now it's probably going to say, oh, wait. Oh, I need a character set. So let's just put the character set inside, because people probably don't need to know that piece of information, so I'll hide that in there. And now look what's happened to the code. The code that we have to read says, oh, what are they doing? He's making up a bunch of test data for students. He's making up a file name. He's turning the file name into a path, and then he's proceeding to write out the file. How do you write out the file? Well, you open up a file, and you go through all of the students, and you write what? How do you write one student? Oh, well, if you want to see how to write one student, it's down there. Okay? So the goal of this game is to take something complicated and now split it into the various parts and give it good names so that you have some sense of what the program is doing. And the other advantage of that is in the long run, we can test each one of those separately. So we can find a way to write a unit test that says, oh, I wonder if I can just write out one student. Oh, I wonder if I can write out many students. In order to do a unit test, you basically need a function to test. In the other case, there was no function, there was just a main program. Now we have some separate functions that we could conceivably supply unit tests for. Okay? So we've succeeded, hopefully, in breaking that thing up into a bunch of smaller pieces. Okay, so hopefully at this point we're sort of done with writing out students. Oh, one final thing. What are we missing from write one student? How much data does student actually have in it? The driver, or in this case that function, writes out just first name and last name, but the student also has an age variable. And so just to be thorough, I should also write out the age variable to the file. So let's go in here, and now we know it's just in write one student that it needs to change. So we'll make a string age is talk to who dot get age. Oops, but that's an int. How can you turn an int into a string? Has to be a string in order to write it out to a text file. Couple of ways.
I thought if you concatenate a string with the number, it automatically...
Well, okay, so let's give that a try. The suggestion was, oh, we've got a number there, which is an int that comes back from getAge. So if you want to turn it into a string, you could try to concatenate it with something. So how about that? There's the easiest way, right? So the Java compiler is smart enough to figure out, oh, okay, that thing's an int, and if you take an int and you add it to a string, it's got to be a string as a result. Off you go. Now we've got a string. Okay. There's a couple other ways of doing that. Want to see another way? Just for the pure fun of it, let's do a different way. Oops. Let's just to separate it out a bit, I'm going to do it as int current age is who.getAge. Okay, and so now I've got something that's truly an integer. If I want to convert it to a string, I'll just reuse the age variable. If you look at current age, when you type current age dot anything, there's nothing you can do because current age is an int, so it doesn't have any methods associated with it. But what you can do is you can turn that thing into a big I integer. Let's see if I get lucky with this. Semicolon. Oop, I shouldn't reuse. So here's the second slightly longer way of doing it, but it's got some interesting stuff in it that we'll see. Okay? Notice this big I integer class. Big I integer only has a small integer inside it. If you go look at the class, it says class big I integer, and then inside they've got a little tiny int. Why would they do that? Because in some cases, for instance, if you're storing things in a list, an array list will only accept objects. It won't accept float, int, and all of those small things. So what do you do if you want to store a small native value inside an array list? You put it into a big I integer, which holds on to the little int, and now you can store the big I integer object. Okay? So that's one trick for the thing. The other trick for the thing is that since big I integer is an object, you can also get it to do things for you. So here's current age integer. And if you type a dot, all of a sudden, since it's an object now, it has other things that you can do with it. So notice that you can convert an int to a float, you can convert an int to a long, you can play all those sorts of games with it. And one of the interesting things is that if you do a toString, it will manage to convert the thing for you. So let's do integer dot, actually there's a couple of different ways of doing it. Okay, so there's the slightly longer way of doing it. Go grab the age out of the student, make a big I integer that holds on to that number for you. And then big I integer happens to have a toString, and toString will do its job somehow of magically converting that native variable into a string for you. This one ends up being more useful because integer has things like integer.parseInt, and so you can use it to go the other way also. You can take a string and it will give you back a native type. So it goes in both directions. It will convert a string to a small integer, and it'll convert a small integer back to a string for you. So they're very useful types. By the way, there's also one for float and double and all of those sorts of things of their corresponding type. Okay? So I'm going to leave both ways in there just because they both work, and sometimes this one will have more advantages than just being able to do what's essentially a toString that way. Okay. So we've got that working, hopefully. Let's just turn around and call the driver. Terminates it. Where's our output going to be? In this myfile.txt. So we'll take that thing and we'll open it. And yeah, we know it's changed because it just got written. Oops, not there yet. Let's go back and look at our code. Why is it not there? It's not in the result string, right? This result string only concatenates first and last name. We forgot to add in, oh, I guess we need a string that also contains the age. Okay, so we'll try that one more time. Write it out, go open myfile.txt again, say yes, I know it's changed. And there we are, almost, except we need a blank in there to prevent the strings from running together. And now we have the ability to write out a complete file. Yeah, question?
Isn't it pointless to convert the age variable into a string at the top when you're just gonna convert it to a string in the result name?
Yeah, there's a couple of pointless things here. The first pointless thing is, yeah, he's right. There's no need to do this because you could have just done it down here, right? Okay. The reason for me showing you that is that that's also a decent little trick to know. And so I'm just showing it to you to file away and go, okay, there's something I might need. And the same reason, it's sort of pointless to do this the long way, but sometimes knowing that that big I integer class is there, you'd be surprised at the sort of things that it can do for you. And so that's just another one where, however pointless it is, it's another good little tidbit to remind you, oh, okay, go look at big I integer sometime and see what it'll do. And the bottom line is, one way or another, really all that you have to do is get to that point and write it out. Okay, so now we've got a piece of code that writes a whole bunch of things out. Suppose we wanted to go the other direction. Suppose we wanted to read all of the students back in from a file and put them into a list, which is also a fairly normal thing to do. Somebody gives you a text file. We've written it out. How do we get it back? How do we reconstitute it the other way? Okay, well, let's give that a try. I guess if we were to reverse the process, instead of write all students to file, it would now be read all students from the file. Okay, and instead of giving it all students, you would now expect that the list of students would come back to you. Okay. Don't have students to start with. Here's the file. It should return you a list of students that you can now use. Okay. So now we know that we have to write this method. So I'm going to go down and I'm going to put that as a method. Oops, and this returns a list of students. Read all students from a file. And this thing is going to be a path that's supplied. So what's Pfeiffer's rule when you've got a method that returns something? In this case, it's returning a list of students. What's the best thing to do to start writing this method?
Add a no return statement.
Well, you have to return something. So here's the little trick here. Well, if it's going to make me return something, let me make an empty list and send back an empty list. Okay? So I'll make a list of students, bunch O student is a new array list that can only hold student. And since it's Java 7, I'll get rid of that word and just make our new array list. And then eventually, someplace along the time, I'm just going to return the bunch of students. Okay. So it's broken because it returns an empty list, but at least it does something. Now we can go back in here and figure out, oh, okay, how do we actually populate the list with the students from the file? So we'd have to go through all of the stuff that's in the file, one line at a time. I wonder if we can steal some stuff from.
Could you do a while loop there?
Well, we might, but before we get to the actual while loop, let's take a look at write all students to file. One of the nice things about Java is that they're at least pretty consistent in their names for these things. So if you had to make a guess at what that name would be, what would you change it to?
Reader.
Reader. Okay. And how about, that one changed to reader? They're actually really consistent once you've seen one. Okay. So what we can do is we can morph this example of code that we've got into, let's just see if we can get it to read. Okay. By stealing what we've already got. So I'm just going to take all of this code here that said write all students, and I'm going to plop it back into here, and I'm going to change it from buffered reader or writer to buffered reader, and change this thing to buffered reader. And that's bunch O student, which is sort of wrong there at that point, because we're not trying to read from the array, we're trying to get an array, so that part is probably going to have to disappear. Do the import statement, and oh look, there's buffered reader, and this is the code that's going to have to go away, so I'm just going to leave it there for a second and do add block comment and see what we can figure out to do here. So what kind of loop should we write in this case? How many things are you expecting to read from the file? As many as there are lines, or basically we don't know unless you went and looked. You just want to keep going as long as there are lines to read. So there's this idea of uncertainty. I don't know how many lines are in the file. So anytime you get uncertainty, that pretty much always means a while loop. So while writer dot, let's just see, would we be so lucky? Oh look, there's writer dot read line that reads a line of text. And it says it reads up until it finds a reline, and it throws an exception for some strange reason, but we'll give it a try. What do you think it would return if it had an error? What would it send? What do you think? Just guess. What would it send you back if there weren't any more lines and you said read a line? -1 would be if it was returning an integer, but it's actually returning a string back to you. So if it can't find one, your expectation is, oh, maybe it sends back a null. Now, writer.readLine does return a string, so we need a place to put the string that it sends back. And so right in here, I'm going to say, actually what I'm going to do is I'm going to make the string here, make it an empty string, and then I'm going to assign a line in here to whatever writer gives back. Oops. That middle mouse key is just getting me every time. Okay, so this is fairly typical for a while loop. I'm going to make a string variable up top that's empty. I'm going to go through and I'm going to ask readLine to read something into the string. If it's a valid thing, then we'll proceed along the way. But we'll do a check here to say if the string that comes back happens to be null, then we're done. Okay? So really typically in a while loop, you'll find that that condition is encased typically right in there. Okay? So even if the file is empty, what will happen is it will fail right away because readLine will return a null and we'll be done. So it works for the empty case. If there is something there, you proceed to do something more. What do you want to do with your line? What's the simplest thing that you can do at this point, just to see whether or not it's working? Yeah, print it out. Okay? Don't have to worry about turning it into an object yet. Let's just see whether or not we're getting something that works. So we'll just print out a line and see what happens. And it looks like I've still got a little, oh, there, my X is gone. Okay, run the thing. And nothing came out. Okay, we'll put a breakpoint there. We'll run with the debugger. There's the line there where it's supposed to be doing stuff. Do a step over. And it didn't print anything out. It just eventually quit. What's wrong with that code?
At what point did you tell it what file you wanted it to read?
Didn't open the file. Let's just go take a look and see. There's the opening of the file right there. Even though I called it writer, I guess I should call it reader. Still the same thing. The variable name is now wrong because we stole that code. Go back and look at my Java version for a second.
Would you let not equal now? I don't understand that part.
It's not while the thing is empty, it's while the thing is not empty that we're going to do stuff. So we'll change it to not empty. Give it a run through. And oh look, there they are now coming back out of the file. Okay. So what's the next job here? Oh, I can get rid of that. We know this part's working. What do we have to do in place of the print line? But we don't have students yet. So even all that we've got is a line of text, Fred Flintstone 23, right? It's a string that contains 3 values.
Add it to the list.
Can't add it to the list, it's not a student. All that you have is a string with one string that happens to have 3 pieces in it.
Use regular expressions.
You could make a constructor for students that breaks it line up into.
You could make a constructor for a student that takes a string and splits it up, or you could do the splitting first and then use the regular constructor. So we have to somehow split up that string into 3 pieces. Do we have anything that will help us split it up?
Well, we have string functions and we also have regex.
What did we look at the other day that was useful?
Split a string by
Split on
spaces.
What did we use to split a string the other day?
Split.
We chose space.
We did it a few days ago. Remember our friend the scanner class? So we'll give the string to the scanner object and let it help us out. Okay. So there's the scanner. So there's 2 ways that you could go about this. Scanner has the while idea in it. While there's a has next, go get me the next thing. But in this case, we know that there's only going to be 3 values in that string that we need. So we're not even, and we're going to hope that the file has got 3 things per line. So we're not even going to bother with error checking at this point. Let's just go get the values. We'll go get the first name is talk to the scanner and do scan.next, which returns a string. We'll talk to the scanner and get the last name is scan.next to grab the next piece out of the thing, which is also a string. Now what do we do about age? Age is a string, but we want it to be an integer. So we're going to have to convert it from a string to an integer. There is integer.parseInt that'll do that for you. So one way that you can do it is you can say string age string is scan.next. Okay. And then you can convert age string with the capital I integer class. So here's another use for it. It has parseInt, where you can give it the age string and it will convert it for you. Okay. So now you've got all 3 pieces of the object. You can make yourself a new student. With first name, last name, and age. So there's your new student. And then you can turn around and you can dump the student onto the list, which is buncho student dot add a student. Okay. So it's almost the same as what we wrote for writing it out, except going in the other direction. Right? When we wrote it out, we had to go grab the 3 pieces of the student out into variables and then write them out. In this case, we're going and grabbing the 3 values of the student that are strings as separate variables, making sure we convert the integer, making a new student object, and then adding the student object to the list. And then eventually this thing returns the list of students that we've now built back out to the main program. Yeah.
So the default delimiter for the scanner is just
It's a space. Yeah, you can change that. We used it the other day when we had name equals value things to change the delimiter to an equal so that we can parse that out too. Okay. Scanner is a handy little class, by the way, because here there's also scan dot. You're going to enjoy this one. Next, where is it? I'll find it. Look, there's next int. So scanner actually already has that functionality built into it. If you want to avoid doing that, you can say, just do the shortcut here. Rid of the age variable and just do it that way. Okay? So scanner just basically calls integer.parsing for you and just says I'm expecting the next thing on the line is something I have to convert. Okay? So there's this idea that the scanner class is still fairly handy. Okay? We're not going to print it out there, but what we'll do is we'll go back into our main program and we'll say for student who in copy of students and I guess I wiped out that printout someplace, didn't I? But we'll just print out who dot first name just to see whether or not we get something without the program dying. Who dot get first name. Save it. Run it. And now there's Fred, Barney, and Wilma coming back at us again. So not only do we have a way of now taking stuff, writing it out to a file, we can read it back in, and notice that when we read it back in, the side effect is that we can get a copy of the thing. So you can either get a copy, or if you don't want a copy of the thing, you could just assign the original all students variable back to there, and it would wipe out the original and replace it with whatever it read from the plot. Either way works. Okay? So we went through a lot of trouble, but we can now go back and forth with writing objects out as strings, reading them all back in. Next time around, we're going to find a simpler way of doing it. That's a lot less work. Okay? A couple of simple ways. So we'll see you tomorrow.